We're going to be talking about motion, and you need to be taking notes in your scientist notebook as we talk about motion. We have a couple of big concepts, but the main concepts that we need to leave with today are going to be speed, velocity, and acceleration. By the end of this, you're going to be able to work with motion graphs through a series of practices with virtual motion graph card matching. Let's take a look at some people in motion. Here's Miss Buck and Miss Pearson taking a walk. Or are they? Sometimes it's hard to tell what's actually moving. How do we know that something is in motion? How do we know that it's moving? You might be sitting in a seat right now, and maybe you're going 0 miles per hour. Or in science, we use meters per second, so maybe you're going 0 meters per second. That means you're not moving any amount of distance in any amount of time. But even though you're sitting still in your chair, how fast are you moving around the sun on the earth? Maybe you're moving 23,000 miles per hour. You know, that's much faster. It's much, much faster, but you just feel like you're sitting still. Now, what if I told you you were going even faster because the sun is also moving through the Milky Way, and the Milky Way is moving through the universe? Now, maybe you are going 286,000 kilometers per second. Well, you won't be. That's faster than light, but maybe meters per second. Maybe you're going very quick, but is that useful? If you're trying to think about how long it takes to the grocery store, does it matter how fast you're going through the universe? Does it matter how fast you're going through the Milky Way? Does it matter how fast the Earth is moving around the sun? Now, what matters for you getting to the grocery store is the fact that you haven't even gotten out of your chair yet. So we need to have a frame of reference when we talk about motion. So you might watch a plane fly by and it's going 450 miles per hour, but Carl Jr. here is sitting in the plane so still that he can comfortably sleep. Now, he might be in the plane, okay, and the plane's going, let's say, 400 miles per hour. But he doesn't feel like he's going 400 miles per hour. He doesn't feel the wind in his face. He can easily stand up and walk. But if he walks this way at 5 miles per hour, to him, he's just going 5 miles per hour, which is a pretty good walking speed. But what if he walks backwards at 5 miles per hour? Then he is going 5 miles per hour in his perception. Now, if you're looking at him from outside the plane, when he walks forward, Carl Jr. is going 405 miles per hour, which is faster. But if he's walking to the back of the plane, he's only going 395 miles per hour. And none of that matters to Carl, because to him, he is going 0 miles per hour. Now, he might also actually be going 0 miles per hour because he's going to feel the same whether the plane's sitting on the ground or whether it's flying through the air. Now, he'll feel unsafe to take off because of the change in gravity. But Carl Jr. has a different frame of reference than someone watching outside the plane. A frame of reference is the perspective that you measure or observe something from. So Carl was observing it from inside the plane and you were observing it from outside the plane, and both of those are useful for different places. If Carl's wondering how long it's going to take him to get from Kingsport to Kalamazoo, Michigan, he's going to care about how fast the plane he's in is going. If he wants to get to the bathroom, he's not going to care about that. He's going to care that he can walk comfortably inside the plane. So we have to pick a useful frame of reference.